Hello everyone and welcome to my YouTube channel. My name is Shubhashish Mishra and today's topic of discussion is on feature scaling. Let's first understand what is exactly feature scaling. Feature scaling is an important aspect of machine learning lifecycle where we try to scale down the features to find out the relationship between features. Let's first understand about the feature. What exactly is a feature? Before understanding how to scale down the feature, we need to understand what exactly a feature. So whenever we have a data set, in case of machine learning, whenever we will be receiving any data set, whatever the columns that are being available in that data set, those are called as individual features for that specific data set. Now, a feature has two different values. One is magnitude and the second one is unit. Let's take an example. For example, if we have a age as a feature and we have a value as 30 years old. So if somebody is a 30-year-old, then over there 30 is actually the magnitude. The value of that feature is the magnitude, and whatever the unit of measurement, that is the years, will be the unit for that. All right, let's understand the feature scaling. What exactly is feature scaling and how does the features look and what does feature scaling do to our data set with an example. Let's say we have a data set that is height that has three features. One is height, weight and age. So here, for example, our aspect is to find out the age of a person based on the height and weight provided. As you can see over here, we have three different features and all of them are having three different measuring units. If we watch closely, then height has a measuring unit of centimeter, whereas weight is having a measuring unit as kilogram, and age, the dependent feature, has a measuring unit of years. In this way, for example, let's say this is a sample of the data that we have. Let's say we have 100 data units or 100 number of rows available for this data, and I've just taken top 5 data, like top 5 rows of the data. From this, and after analyzing everything else from this data set, we understood that okay, the data set is actually following a linear pattern. From the output value, that is the age that we are finding out, we are seeing that it is following up a linear pattern. So in that way, we started to understand, okay, let's go ahead and create a linear regression model. So in this case of linear regression model, whenever we will be fitting this data into a linear regression model, there our prime aspect will be to find out the best fit line which can be able to get us the best value for the output that is going to be predicted. So in that aspect, whenever we will try to find out the best fit line, definitely whatever the output we'll be receiving as the predicted output, definitely we will be having some sort of error. Based on that error and the best fit line what we are drawing, if we take that coefficient of that line and the output that we are receiving, the loss that we are getting from the output, by subtracting the output, exact output and the predicted output, if we draw it in a xy plane, then we will be receiving called as gradient descent graph. So in that graph, the aspect of ours is to find out the line, a best fit line, which has having a minimum loss. As over here we have three features, that is height and weight as our independent and age as the dependent feature, and the measuring units are completely different. Based on that, if we will try to draw the gradient descent curve in that way, we will be getting these let's say we are drawing the features and feature 2. So over here the convergence will be very difficult because we have two different units. Now on the contrary, if we have scaled features, then what we are doing in case of scaling, we are actually converting the data into a specific scale, that is, for example, maybe 0 to 1 or 1 to 10 or 1 to 5 or 0 to 5. We actually put a scale, and in that scale we convert the height, we convert the weight, In that way, we have a common measuring unit, and that measuring unit has a common distribution, and every data point we have is actually forming inside that distribution, and hence we have a scaled data. Based on those scaled data, once we try to draw the best fit line, with the chances of getting the convergence of the global minima is actually increasing. So this is how we can be able to see, if we have a scaled feature, then from that scaled feature, the chances of reaching out to the global minima is getting increased. A lot of algorithms, like in linear regression, because the idea is to find out the gradient descent, the global minima, definitely we need feature scaling. In case of any algorithm which is related to distance algorithm, for example, if we are using Euclidean distance or Manhattan distance, in algorithms like k-means clustering, or in algorithms like KNN algorithm, k nearest neighbor, in those kind of algorithms, we definitely need feature scaling, because there we need to have a single measuring unit to find out the effective distance and to make the model having a better understanding of the data, and in that way making the model predict better. We will be having a detailed discussion on these scaling techniques and their uses in the next video for sure. But the agenda of this video was to make you understand what exactly is feature scaling, and now how to perform the feature scaling using standard scaler and min max scaler, that we will be discussing in our upcoming video. Until then, stay tuned and enjoy machine learning. Thank you.